Hi guys, so in this lecture we'll be starting on seeing the laws of thermodynamics. So these laws are defined for microscopic systems. So first let's get started with the zeroth law of thermodynamics, which is based on thermal equilibrium, which says that if two systems in thermal equilibrium with a third system, then they are also in thermal equilibrium with each other. Two systems in thermal equilibrium with a third system are also in thermal equilibrium with each other. Okay, so pictorially, if I represent system A with a rectangle and marked A inside it, and a system B, they both are in thermal equilibrium with, let's say, a system C. Now zeroth law says that if these two are in thermal equilibrium with each other, that means that if a system A is at temperature T, and then this would also be at temperature T, and we are also given that B and C are also in thermal equilibrium with each other. So if the C's temperature is T, then the B's temperature would also be T. Then according to the zeroth law, if these two systems are in thermal equilibrium with a third system which is C, then these two would also be in thermal equilibrium with each other. Okay. So next let us see first law of thermodynamics. Okay, so this is based on conservation of energy. So this is based on energy conservation. Okay, so which says that energy of a universe remains constant. Okay, so let's first see the differential form of first law of thermodynamics. So which is du is equals to dq plus dw, and when we integrate these respective terms we will get integral of du which would be equal to integral of dq plus integral of dw, which would be nothing but delta u, which would be equals to q plus w. As q and w are path functions, so we won't be representing it with delta q, neither we will be representing w with delta w, as we have already seen in past lectures. So this is the integrated form of first law of thermodynamics. Okay, next we will be seeing for an isolated system, we can say that as for an isolated system, no work is done and the heat transfer with the surrounding is also zero for that particular system. So we can write that q and w both will be zero, and if q and w both will be zero, then we can say that delta u would also be equals to 0, as delta u is equals to q plus w. Okay, so we can also write that if delta u is 0, then we can write that kinetic energy and potential energy, which is nothing but the total internal energy, would be constant. Okay, and for a cycle system we can say that integration of du, which is this integration sign shows that uh, this is integral over a cyclic process. Okay, so we can write that du would be equals to cyclic dq plus cyclic dw, and for a cyclic process we can write that del du would be equals to 0, or in other words we can say that del of dq plus del of dw would be equals to 0. Okay, as u is a state function, hence for a cyclic process something like this. So I'm just showing this, but for a cyclic process, as du is, or rather u is not dependent on the path, so if you go from one point and again reach the same point, then delta u would be 0. Hence closed integral of dq plus cyclic integral of dq plus cyclic integral of dw would be 0. Okay, so we know that s del u is equals to 0. For a cyclic process we can write q plus w would be equals to 0. Okay, so this simply means that uf is equals to ui and q plus w is equals to 0. Okay, so for the same we can write that in PV work or in expansion and compression work, we can write that dw which be equals to minus p external multiplied with dv. Okay, and for gas expansion we can write that dv would be positive, hence dw would be dw would be negative. Why? Because this as dv is positive and dw is minus p external dv, so dw would be negative. And in gas compression we can say that s dv would be negative, hence this implies that dw would be positive. Why? Because this is minus p external dv, and as dv is negative, dw would be positive. So with this we come to the end of this lecture. In the next lecture we'll be seeing more on sign convention. So till then, good luck and goodbye.